For this video is to do an abrupt change, a two-way drainage, and we're going to make beta not equal to half. So in terms of our flowchart, we're looking at an abrupt change, beta is not equal to a half, and we're doing two-way drainage, so we're down here. Now, we've been given pretty much the same case we've been seeing before, 8 meters of soil profile, a sudden increase of 100 kPa, but our CV is now 1 meter squared per year. So if we were to use the same values before, we know beta equals CV change in T and change in Z squared. So CV is 1 if we want an increment of time of 1 year, and a change in Z of 2 meters, so that would be 2 squared. This would be 1 on 4, which is not equal to a half, and this also needs to be less than or equal to a half. So that is less than or equal to a half, and that means we can do it. Now, I would not recommend doing it this way. Once again, it's always much easier to use beta equals a half, so setting these values such that beta equals a half. So you'd want to find a change in T and a change in Z for this new case such that you still get a half, because it's much easier. But we're going to do it just to show you how it's done if beta does not equal a half for some reason. So we're still dividing our layer up in increments of 2 meters. So we're going to come and draw up our table as we always do. So we have time, the stress, the change in stress, Z equals 0, Z equals 2, Z equals 4, Z equals 6, and Z equals 8. We look at time year 0, we would look at year 1, we would look at year 2, year 3, and let's do year 4. Okay, so we rule this off. Now, we'd once again find the load at any point. So at any point, at any time, our load is always 100 kPa. So this is all 100. Just like before, the change in load is 0 everywhere, except at time 0, a point just before time 0 was 0, and a point just after time 0 was 100. So we're getting an abrupt change of 100, but at any other time, there's no change in load from year to year. We would then rule this off, and we would find the boundary conditions. So we have said that it's two-way drainage, which means that the excess pore water pressures will dissipate through the top and bottom, and we know that means that we have no excess pore water pressure at our top and bottom layer, except for the first case when we immediately load the soil. We get a sudden increase of 100 everywhere, which is felt by every single point in the soil. So that's 100 everywhere, and now we can march the solution forward. Now, because beta does not equal a half, we know that beta equals a quarter in our case. We're going to have to use the different formula. So that formula will look like this. UB of time 2, so the pore water pressure in the future, is its previous pore water pressure, so UB of time 1, plus beta outside of UA of time 1 plus UC of time 1 minus 2UB of time 1. That's all in brackets outside of beta. And then we add on the change in stress. So I'm going to do the first couple slowly, like we always do. So looking at this value here, we need UA would be this value, UB would be that value, and UC would be that value. So we would have UB would be 100 in this 100, so it'd be 100 plus beta, which is a quarter, outside of UA, which is 100 plus 100 minus 2 lots of 100 plus the change in stress, which in year 1 is 0. So if we were to work this out, we'd get this 100 plus 100 minus 200 is 0, so we would just get 100. Similarly, if we wanted to work out every other point, it would be 100 in here. We're going to do this one here, which is going to hopefully demonstrate the difference now. So for this one, so UB of time 2 would be UB of time 1 is this value, so 100 plus the beta, which is a quarter, outside of UA of time 1, which is 0, plus UC of time 1, which is 100, minus 2 lots of UB of time 1 again, so minus 2 lots of 100, close bracket, plus the change in stress, which is 0. So this would equal 100 minus 2 outside of 100. So that's minus 100 times 0.25. So this would be 100 minus 25 plus 0, which is 75. So this would give us 75. This would give us 100. The reason I found that is because it's 100 plus a quarter outside of 100 plus 100. Sorry, this is 100 because it is 100 plus 100 minus 2 lots of 100, which takes this whole thing to 0. So it's just going to be UB of time 1, which is 100, and this will similarly be 75. So I'm not going to go and work out every single one of you. You guys can do that in your own time, but that is how you march it forward using this formula. So all the other values would be, this would be 62.5, this would be 87.5, this would be 62.5, this one would be 53.1, this would be 75, and this would be 53.1. And as we know, as time approaches infinity, the excess pore water pressure at any point will be 0. Just once again, just to show you how I found one of these points, if we were to look at this one, so the UB, which we found to be 53.1, the way we found that was we took our previous UB, so that's 62.5, plus 1/4 outside of UA plus UC, so 0 plus 87.5, minus 2 lots of our previous one, so 62.5, plus the changing stress, which is 0. So if we were to double check that, 87.5 minus 2 outside of 62.5, times that all by 1/4, plus 62.5, plus 0, we get 53.1. Okay, so this situation, the way this formula applies to every single point within here, and we just march this solution forward. So this now shows us the excess pore water pressure at any given time, so at a increment of time and at an increment of depth. Anyway guys, hope that helps.